So let's go ahead and get started here. We're going to discuss a few different things. First off, really dealing with the idea of BGP community strings. So community strings in BGP are used for quite a few different things, as a matter of fact, right? But think of them as the idea of nothing more than a tag that we put on the individual route itself. Now that tag can then be used for multiple things. In an MPLS environment, you're going to see the tags that we apply to it are what they call an export route target. And that export route target, which is nothing more than an extended BGP community string, is eventually used by another provider edge router to determine which virtual route forwarder do we apply that route to, okay? So which routing table do we put it in for an individual user? What we're going to show you in this case is think of more like internet routing rather than the idea of an MPLS environment. How can I tag a route and allow a service provider to utilize that tag to make changes to different BGP attributes, okay? And that's what we're going to be doing in this particular section. So they're going to show you a few different things, just simple, what is a community string? And they go through and they mention a couple of different things as far as selecting the proper return path. In this case right here, and hang on, let me bring up one other thing here. All right, so we get to see from this customer perspective, and this customer is in an autonomous system 213 in this case. Notice we got two different service providers. One has a 2 meg connection, one has a 64K connection. So obviously our desired path would be to use the faster link that we've got available for us. And we can use things like a weight attribute to go through and determine what is our best path going outbound, or a local preference can be set within there. The higher the weight or the higher the local preference is the more preferred route on the way outbound. Right? But the problem with it occurs with what happens when we have return path traffic. Like, let's say I'm trying to reach some customer that's connected to the service provider in autonomous system number 387. As my preferred path outbound goes in this direction to reach that customer. The return path, however, is not my decision, right? It's as that traffic comes into autonomous system number 387, they're going to determine what is the best path to get back to this 10 network. And their best path is going to be based off of autonomous system linked, okay? So by default, you're going to see that it's coming in this direction. And we get this asymmetric routing occurring at this point. Now, we can do things like AS path prepending. AS path prepending allows for us to say when we're advertising this 10 network out in this direction to that service provider, what I'm going to do is to prepend my own autonomous system number multiple times to that path. Right, so it looks like a 213, 213, 213, 213. Right, and again, the other path, as we send it out in this direction, we're going to leave that alone, not doing any AS path prepending. So by the time it reaches this autonomous system 387 out over here, you'll see an AS path of 462 and then a 213. And it says, well, this path has only 2 autonomous system numbers in that path versus this path right here that has 1, 2, 3, 4 autonomous system numbers in its path. And it prefers the best route going outbound through autonomous system number 462. The problem with that is that the more autonomous system numbers you have in a path, the more memory it consumes at the service provider routers. Right? So a lot of times what you'll see is that those service providers are going to not allow you to do things like AS path prepending. I don't want to use more memory on my internet router at any given time. And they show, how do you select the proper return path from autonomous system 387 without using AS path prepending? Well, we could go into autonomous system 387 and I'll use a local preference. But I don't have any way of being able to do that, right? The service provider would have to do that on their own. And they show, you think the administrator of autonomous system number 387 is going to configure that? Probably not, okay? What they're trying to do is to have some way of being able to say, I can have a list, do this, do this, do this, and it tells me what you want me to do as a service provider, okay? And that's what we're going to utilize things like these BGP community strings for. I'm going to set a community string as I advertise outbound to this autonomous system 387. And I can set it on this other link as well. okay? Now, these community strings are a 32-bit number. Typically, what you're going to see within here is that the first portion of it is the autonomous system number of the service provider that this community system is going to be meant for, right? So I can go through and say, as I advertise this 10 network out through the top link, do a 387 colon, and then maybe a 150, for instance, right? As I advertise this out through the bottom link, I can advertise a 387 colon 50. Now, again, they're nothing more than tags on that route. As we receive that route coming inbound on this autonomous system 387 out over here, what they will do is they'll set up a community string access list to say, if I ever receive a 387 colon 150, what that tells me to do is to set the local preference to be 150 for all of those routes. If I ever receive a community string of 387 colon 50, what I'm going to do is set the local preference to be 50 on those routes. And again, the idea at that point in time is that I've set this tag that doesn't use much more memory at all as it gets into this autonomous system 387, and they're using that tag in a route map to set the local preference in their own local autonomous system. And by setting that local preference, now they prefer the path going in this direction. Remember, we're looking for the highest local preference would be the most preferred route, okay? And that's checked even before autonomous system path link in the BGP path selection process, okay? Now, these can do a lot of other things as well, right? And not just necessarily setting local preference. I could have autonomous system 387. As they send that advertisement outbound to other service providers, go through and match that and do ASPAC prepending for me, okay? So I might go through and have a community string like a, let me write it in a different color so it's easier to see, a 387 colon, let's say 3, for instance. And what they may do is to say, if I receive this 387 colon 3, what that does is to do ASPAC prepending, and they're going to prepend 3 times in this case, their own autonomous system number, okay? So lots of different options that we have available for by utilizing these tags to tell the service provider what it is I want them to do with my individual route. Now, obviously, this is something that you've got to coordinate with your service providers. I need to know what community strings they have set up and what are those community strings going to do in their network so that I can utilize that to be able to determine how do I actually send traffic back and forth. Now, one thing you've got to remember is that when you deal with community strings, they are an optional non-transitive attribute. All right, so you're saying, so autonomous system 462 would pass on the community tag along with the prefix. Other AS would just ignore if that AS doesn't match your own. Absolutely, okay? Now, again, like I was mentioning, the idea of these community strings being an optional transitive attribute, they're not sent by default from one neighbor to another neighbor, right? So we've got to go through and configure that information. You'll see that they've got a neighbor and the IP address of your neighbor in BGP, send-community. It says, make sure that we're sending those community strings out onto those neighbors, okay? It being a transitive attribute means that if it comes into autonomous system 462 up here at the top, even though it doesn't know what to do with those community strings, it can pass that along to another neighbor. In this case, autonomous system 387 down at the bottom. But it's got to be configured to do that. Now, that being said, it's one of the reasons why a lot of times we're utilizing local preference. Let me explain what I mean by this. If I've set on my route as it goes out in this direction, a 387 colon 150, and I've set as it goes out in this direction, a 387 colon 1 or 50, excuse me, like I said before. And they've got it set up an autonomous system 387 to use these. If I see the 150, I'm going to set a local preference of 150. If I see the 387 colon 50, I'm going to set the local preference to be 50 for that. Now, if autonomous system number 462 does not send out community strings, what you would see happening is as it advertises that information out onto autonomous system 387, 387 is not going to receive that community string. But I still receive this community string coming inbound from my customer. And when I see that 387:50, I'm going to set the local preference to be 50 for that route. Now remember, the default local preference out over here is 100. So even though they don't receive the community string, there's still a local preference on that value. If I'm saying my backup route that I'm utilizing out over here shouldn't be used, I want to set that local preference to something lower than the default value. Now, typically anymore, most service providers are sending community strings between different providers, okay? So you're going to see a lot of that actually being advertised back and forth. It's usually one of the things that they do for any external neighbor is to send out BGP community strings anymore. And they mentioned the idea that community strings is nothing more than a means of tagging an individual route. And I said, we're going to use that tag to eventually go through and determine what we want to do within our BGP attributes. They're going to match that tag or that community string in a route map and then set a local preference or set a multi-exit discriminator or set ASPAP prepending, right? So we can do all sorts of fancy things within here based off of what we're doing in a route map. Okay. They show any BGP router can tag these routes on both incoming and outgoing updates, or when you're doing redistribution from things like OSPF into a BGP, or if you're doing things like a redistribute connected, for instance, into BGP. They show all the BGP routers can actually filter routes based off of those incoming and outgoing updates. And again, as we're doing things like redistribution, they show by default community strings are stripped in any outgoing BGP update. Again, the idea that it is an optional transitive attribute, unless we specifically tell it to, BGP will strip off those community strings as it gets sent out onto another neighbor. Okay. So we're going to want to make sure that they're propagating those BGP community strings. We're going to talk about the idea of defining a community string. We said it is a 32-bit number. It's typically split into two different parts. The highest order 16 bits contain the autonomous system number that is really going to be utilizing this community string, if you will, okay? That AS then uses the last 16 bits to go through and say, what is the meaning of that community string? Okay. They show values of all zeros and all ones. The higher order 16 bits are reserved, and you'll see that that's not an autonomous system number either. They show the iOS allows you to actually specify it as AS number colon and then a lower 16 bits that we utilize. So what do we have to do? We have to find out first off, what are we trying to get with this particular route? Am I looking for a primary and a backup type of solution? Am I trying to get load balancing to occur? Right? So we have to define what our goals are going to be on what's going to be the best path back into my network. Remember, almost all of this community string and what we're discussing with internet routing is about how does the rest of the internet come back into my autonomous system, okay? Then I'll need to define the community strings that are going to be signaled and say what are we going to advertise out onto our different neighbors. I'm going to configure route tagging on the entry points or let BGP neighbors tag the routes. I need to make sure that we configure it to send those community strings because again, they're optional attributes. They are not sent by default. Okay. And then we can configure route filters and route selection parameters that are based off of those community strings, essentially creating a route map to say, if it matches this community string, set this attribute in BGP. To show in this case, so our goal, we're going to solve that asymmetric customer routing problem that we had in that very first slide. Okay? They show we're going to define filters and path selection policy to achieve that. So they show we're going to set the local preference of the customer routes to be 50 for all customers using a backup ISP. Okay? They show we're going to define communities that actually signal those goals. And they show we're going to use a community string of 387:17 is used to indicate that the local preference of the route should be lowered to 50 in this case. Now, As I set the community string, at some point, the service provider is going to have to interpret that community string. And that's where it's going to match a route map. If it has this community string, set this particular attribute in BGP. Okay, so we're going to go through it, configure route tagging with communities, and then we'll configure a BGP community propagation. So we'll go through and say neighbor and the IP address of that neighbor, send dash communities. We'll then define a community access list. This would be at the service provider in this case, okay? So this community string access list that we have created to match those BGP community strings. I'll then create a route map that says if it matches that community string, set this BGP attribute. And I'll apply that route map to either incoming or outgoing updates, typically to incoming updates of the service provider, okay? Again, what you're going to do is in global config, create a route map. So you'll name your route map. You'll match a BGP community string access list. And from there, you can then set a different value. Or I can create a route map and match a certain individual route and set a community value for it. Okay. Now these community strings, notice you can have multiple community strings within here. Okay. So if I go through and say set community, and then I say 387:17, 387:50, 387:160, whatever it may be. And the idea is that if I go through and just set the individual values, any community string on the local route is dropped by default, and they add in these values. However, I can use the keyword of additive to say, keep all of the other community strings that are already on this route alone. Leave them alone. Go ahead and send them outbound to my neighbors. But add in some multiple community strings, okay? Kind of up to you whether or not you want to drop all the other ones and just send the community strings that we're setting, or send all community strings that we have available for that. And then what we're going to have to do is we'll apply that route map either inbound or outbound to a neighbor, okay? So again, underneath BGP, we'll say neighbor and the IP address of that neighbor, route dash map, and the name of your route map, typically on the way outbound to that neighbor, okay? So we're setting those community strings as it goes outbound. Like we said, we can also set community strings as we redistribute from one routing protocol into BGP as well. So here what they've done is they've gone through and created my route map called set community. Notice there are no match conditions, and they're setting the community string to be 387:17. So that would match all routes and apply a community string of 387:17 to all routes as it gets advertised out onto this neighbor. They've gone through for that neighbor. The neighbor's IP address is 1234. I'm sending it through the route map called setcom as it goes outbound to that neighbor. And I've enabled sending BGP community strings. Okay, so I've gone through and said neighbor 1234, send dash community. Again, because that is an optional transitive attribute. Like we mentioned, the idea that it is not automatically sent, we have to go through and configure it to send these BGP community strings out onto that neighbor. As I show you, must manually configure the propagation of the BGP community strings. Okay, now, if you've ever played around with BGP peer groups, which are essentially kind of like a template, if you will, you can apply the send community to a peer group and then have all of my neighbors in that peer group if we needed to, okay? All of my external neighbors in that peer group. And you want to make sure that you're typically sending these outbound to internal neighbors as well. So remember, internal and external BGP neighbors cannot be a part of the same peer group. So they've just gone through and said, not only do we have to use the route map to set the community, but I have to make sure that I'm sending that community outbound to that neighbor as well. At the service provider, they need to go through and match those community strings and then be able to use those in a route map. So they're going to do this by creating what they call a community string access list. So under global config, I'll type in IP community-list and I give it a number, 1 through 99. And then you've got either permit or denies, and then the individual value. And you can have multiple community strings. If I see this combination, I'm going to do a lot of other things, okay? So I can utilize that within a route map. As I show, any community strings are very similar to access lists. They're a top-down processing that you're going to see. All values listed in one single line have to match for that route to match this community string access list, okay? So if I've gone through and I've created a community string access list, now let's say we do a permit 387:17, 387:150, okay? I have to have both of those community strings on the local route for it to match this community string access list. Now, I'm going to tell you quite often, you don't see multiple community strings. It's just one community string in there that we're actually trying to match that we can set information on. Okay. As I show you, you can use the keyword of internet to match any community string that you want to as well. And notice we can also use things like regular expressions. Instead of an exact match for a community string, I can match based off of a regular expression. Okay. As they show, an extended community lists are like simple community lists, but they match based off of regular expressions that we're dealing with. Notice in this case, the numbers from 100 to 199 that we have available for us. They show you can use a dot asterisk to match any community route or value that we have available for us. So at the service provider, what they've done is created a community list, in this case, community list number 7, and they are matching specifically that community string of 387:17. Now they've got to use that community string, this community string access list somehow to be able to change attributes in BGP. And that's what the route map's going to do for us here, okay? Now, in the newer versions of code, I think it was version 12.2 and higher of the iOS, it allows you now to create named BGP community string access lists. So give a more meaningful name to it rather than just an individual number. Again, can be used with regular expressions as well. And there are no limitations to the number of community string access lists we can have now, right? Which was kind of an issue when we were starting to deal with the idea of a service provider and what type of things would they actually want to match if you could only use 200 different community string access lists. Now, they also mentioned the idea that you can utilize within here as a BGP community string link bandwidth. Now, by default, BGP does not look at bandwidth of an individual interface to determine what is the best route, okay? However, with the DMZ link bandwidth feature, it allows us now to enable not only multipathing, right? So we can have multiple links to the exact or multiple routes to the exact same network that we have available with us, but it can be advertised. Let's say if you're learning a route via BGP and I redistribute that in OSPF or EIGRP, the DMZ link bandwidth command allows us to be able to take the external bandwidth of the interface and advertise that to EIGRP or OSPF, okay? So they know what the external link is at that point, okay? Giving you kind of an example of this DMZ link bandwidth. We're looking, assume autonomous system number 100 is our customer network. Autonomous system number 200 is the service provider down here, okay? And notice that we have different interfaces. I've got a 5 meg link, I've got a 1.733 meg link, and a 500K link that we have available for us. So what we want to do is to see this as being our primary, our secondary, and our tertiary type of route that we're looking at, okay? And by default, as I advertise any routes that we've learned off of these interfaces from BGP up onto router A, it doesn't contain any information about the bandwidth of the individual link and what should be preferred based off of that, okay? The DMZ link bandwidth command allows us to be able to advertise the bandwidth of these links in the middle here outbound to router A. So router A has an availability to be able to say, not only we have multiple paths, but one path is the best based off of bandwidth. And again, that is advertised using a BGP community string. So I show you, here's this configuration here. This is router A. So just have a pretty simple communication. I got my neighbor set up. It's in my own autonomous system. I'm using update source loopback 0. Okay. They've gone under the address family for IPv4, and this is where they've advertised. Oops, I didn't mean to do that. They're allowing the use within IPv4 of the BGP DMZ link bandwidth. Okay. And now notice that they've gone through for both of their neighbors, and they're doing a send community. The send community both is the default. It's both standard and extended BGP community strings. And then notice they've also activated their neighbors as well for IPv4 address family to advertise those IPv4 routes out. Here is router B's configuration. Now, couldn't fit it all on one slide, so I've got it at 2 slides. Again, we become neighbors with router A and with router C. They're doing eBGP multi-hop for it. Underneath the address family, they've added in the DMZ link bandwidth command. Okay. And then again, they're activating my neighbor, I'm doing a next hop self, and I'm also going through and sending community streams so I can advertise that bandwidth of the external link up onto router A. Here's this just the rest of it, right? Where they're activating the other router, sending community strings. I activate my service provider, and I've done the DMZ link bandwidth on that service provider. So I've said neighbor and the IP address DMZ link bandwidth. Okay, I've done that same thing on the other link that we have up onto service provider in that autonomous system number 200. They've turned on maximum paths for internal BGP to be 6, and they set external BGP to be 6 multiple paths as well. Okay. Here's router C. Router C is again becoming neighbors with router A, router B, and the service provider that we have. Underneath the address family IPv4, we've enabled the DMZ link bandwidth. I've activated my neighbor, sending out community strings, and I've done a next hop self to my internal neighbor of 10.10.10.1. I've activated the other neighbor, sending out community strings, and done a next hop self. Here's my service provider then. I'm activating that 172.16.3.3, and I've turned on the DMZ link bandwidth. And again, going through and doing a maximum paths for both IBGP and eBGP of 6. Now, we said, as I've set those community strings and I've advertised them out onto our service provider had to create a community string access list to match the community string. Then we'll use a route map to set attributes for those. Okay. So again, you're going to go through and create the route map. It'll be a permit statement in most cases where you're going to match a community string access list, and that can be either a number or a name. And I can use a set command to set things like local preference or await or ASPath prepending if we needed to. Okay. Now they show with the exact option, all communities attached to the route have to match the community string access list. You don't see it very often, okay? Because there may be multiple community strings that are being used within there that we don't necessarily want to match every single one of them. Then we mentioned the idea of route selection. By going through and changing the attributes as the route comes into the local router, it then affects how they choose what is the best path, okay? So they show you can use route maps to set weights or local preference or a metric, the multi-exit discriminator on these BGP routes. They show then the normal route selection rules apply after that, okay? They show routes not accepted by a route map are going to be dropped. They are not put into the BGP table. Now we do have they show them default filters. These are known as standard BGP community strings, okay? So if you go through and use a community string of no export, okay, that tells me I'm advertising the route to my service provider. The idea is that a community with that no export are sent to any internal BGP peers and any interconfederation BGP peers that they have inside my local service provider. but they are not sent outbound to real external BGP neighbors, okay? So my local service provider receives the route, but they're not gonna advertise it outbound to anybody else. I can use a local AS as a community string standard attribute, okay? And again, what you're gonna see with that, local AS only sends it in the service provider's network to their IBGP peers. No longer does it send it to interconfederation eBGP peers. And last but not least, you can have it as a no advertise, they're not sent to any neighbor in BGP. Only the local router receives that route at that point. You see that no advertise when someone's running BGP with a service provider and they've got provider assigned IP addressing and they don't have a public autonomous system number. They've got a private AS number, right? So we're going to strip off those private AS numbers, and I'm typically not going to advertise that out onto other networks. What I'm going to do is going to send out one big summary or aggregate address for my local addressing space from the service provider. So here we see, back to that example within here, they created this community string access list that matches that 387:17. I've created a route map called set local preference. And it says, if it matches that community string number 7, I'm going to set the local preference to be 50. Now remember, the default would be I'd throw everything else away in a route map. So they created another statement in this route map that just permits all other routes. Okay, in case they don't have that community string, they just don't make changes to it, they permit the route however. Okay, and then they apply that in this case right here to our BGP peer group called customers. It's called set local preference inbound. Okay, so if they receive inbound a route that has that 387:17 in this case, right, it matches my route map as it comes inbound, and it'll set the local preference to be 50 for that route. So over here, they see that as a local preference of 50. Remember, the other route, as I learned in this direction, may not have any BGP community strings, and the default local preference for that would be a 100 in Autonomous System 387 here. Now, from what I've seen out of most service providers, this last number right here tends to have a fairly good meaning for it, right? I would rarely see something like a 17 being interpreted as a local preference of 50. Right? I usually see that as like a 387:50, for instance, and 387:150 would set the local preference to 150, and 387, let's say 200 would set the local preference to 200. You start seeing single digit numbers like a 387:3, that's usually things like ASPAT prepend. We want you to prepend the service provider's autonomous system number 3 times. Versus a 387:2, only prepend it 2 times, or a 387:1, only prepend it 1 time. Okay, so the meaning has a lot more significance in most case scenarios to understand what it is that we're actually having the service provider do. But again, you need to know what is the service provider set up for, and what community strings can they use, and what are they going to do with those? So you do need to talk to your service provider to say, or do they have these community string access lists set up, and can we do it using community strings? Now, when you go through and do a show IP BGP, you don't see any of the BGP community strings. You have to actually physically look at the detailed information about that route. So you can go through and do a show IP BGP and put in a prefix. That will give you the detailed information about that individual route. You'll see that community string. Right? As I'm going through and doing debugging, I'm debugging BGP updates, for instance, right? You will see BGP community strings being sent in those updates when the debug commands. They show routes in the BGP table tagged with a set of communities, or routes matching a community list can also be displayed based off of a community string or matching a community string access list as well. So I can filter out what we got in my BGP table by looking at a community string as well. And so here they show, I'm looking at that 10 network. So I've gone through and done a show IP BGP and the specific network at 10.0.0.0. We're now seeing that community string on these individual lists right over here. Okay, where I'm receiving that information from. Notice how the route that goes through autonomous system 462 has no community strings, right? We don't see any community strings on that particular route. And they show you can go through and do a show IP BGP community and specify community string name. If I just do the keyword community, it'll show you all routes in the BGP table that have a community string attached to that route. Or I can specifically look for one individual community string. If I do a show IP BGP community 387:17, it only shows you the routes that have that one individual community string. Okay. If I put in multiple community strings, we can do that. It would only show you the routes that have all of the community strings that you have in that command. And show you can also go through and say, I want to make an exact match of all of the different routes. And I'll mention, we can also look at the entire community string access list, right? So if I do a show IP BGP community list and then the name of my community list, it shows me all the routes in the routing, the BGP table, excuse me, that match that community string access list. That comes up with my summary. I mentioned we could use these BGPs, community strings, to be able to set attributes utilizing a route map. They're usually used between the neighboring autonomous systems, right, like our service provider. Routers that don't support community strings will pass those attributes to other neighbors because it is a transitive attribute. So we have to go through and enable that by making sure that we're sending those communities outbound to my neighbor. To propagate those community strings outbound to your neighbor. I'm show you can use these community string lists to match the community string, and then inside a route map say, if it matches that community string, set this particular attribute in that BGP route. The idea that we've got next on demand, okay? So one thing, Scott, although we do not have the ability, we're not going to give you the slideshow. Anybody who is a Next membership for us at Sunset Learning here, you get access to our digital course library. This is being recorded and will be posted up there on Next as well, so you'll be able to see that. Many videos, all these Tech Talk webinars that we have. You're going to see that they've got all sorts of not only discussion boards where you can get contact with us as an instructor, but you're also going to see them short, like self-study type of things, videos, blogs, articles, quizzes. I'm going to actually go through right after this, as a matter of fact, and record a lab walkthrough and utilizing BGP community strings as well. So just give you kind of an idea. We've got that discounted as well. Regularly $19.95, now it's $9.95. Again, use the code NEXT1K for it. Get $1,000 off. And that's pretty much what I have for you guys, unless you guys have any other questions. And if you have any other questions, please feel free to send me a chat, or you can pipe up as well. All right, then other than that, we will let you guys go. Hope you guys learned a little bit of something about BGP community strings. And have a nice day. Come back to another Tech Talk that we're going to have.